So now that we've taken quad encoder number 2 and created this part, and we've been able to test how far it travels in one revolution. We have our encoder value less than 360. So what we're going to do is think about how we can make this into a quad encoder super user function. Well, this part right here is basically it so far. We've got this information right here. We've got the if statement, and then we have all of this. So what I'm going to do is I'm going to take all of this section right here from the wait all the way down to the stop, and I'm going to cut it, and we're going to put it in a new function. Okay, we're going to add a new function. We're going to call this quad straight, and press OK. And then I'm going to paste in that information. So whenever I run quad straight, okay, and I'm just going to go ahead back over here and drag, I'm on my main, I'm going to drag quad straight in there. Press OK. It'll do if bumper equals, and then it's going to run that little sub program, that user function, that sub program. So this mini program right here, it'll wait 1000 just like we did. It'll start the encoder, run the encoder, and then while the encoder is less than 360, it's going to go, and then when it's done, it's going to stop. Okay. Now, the only thing that we need to make sure of is that our variables are global variables, and we have encoder, which is a global variable, encoder, which is a global variable, encoder, which is a global variable, right? So we don't have any other variables that we're using in here that are not global. Now, this right here will go straight, but we don't control how far it goes or at what speed. So the one thing we're going to be working on first is adding in how far it goes. So I'm going to double click on begin, and we're going to do a double, because we want decimals, and we're going to call it inches. And press OK. And when we do this, it's going to, it's going to respond, hey, you're changing this function, you're going to change it in other places, and we're going to say yes. So when I go back to the main, I'm going to double click on here, and now it wants some information. So what we're going to do here is I'm just going to type in 30, because that's the number we're trying to get to, 30 inches. And we're going to build this quad straight program to drive 30 inches. And that's because that's the number that's going in, so we're going to base it all off of this variable. This variable is going to be what we need to do. Now, in the slideshow that I had up there, you have information that says kind of how do we get there. You need to find out how far you travel in one revolution, get that average. Then you need to find out how many degrees you rotate to travel 1 inch. And that is going to be our unit rate. And that unit rate is what we're going to have to use for inches. Right? So that's what we have to use for inches. So I'm going to do an example that is completely wrong, but it's going to help you kind of get it set up. So what we're going to do is inside our quad straight, we're going to double click on variables and create a long that's called final encoder. This is what we want our encoder to stop at. Final encoder. Now we're going to program flow, and we're going to drag over assignment. Assignment is going to be our math function that we're going to use. So we're just going to use some math inside here to convert our inches into how many degrees we travel using our unit rate. So we've got final encoder equals, and then inside parentheses, we're going to write float, and that's just going to help us with rounding and keeping everything the right values. And so we're not going to truncate anything until we're done with all of our math. And so we're going to do inches times, and let's just put in a number there. This is going to be completely wrong, but let's go with 80. All right, so let's go 80. 80 is going to be our unit rate. So if your unit rate is obviously going to be different, but you can adjust this, and this is going to be what dictates how far we actually travel. So you'll modify this as we go along. I'm going to press OK, and then it's going to do the math. So let's say we type in 30. 30 times 80 is 2400, and so final encoder is going to be 2400. So this is going to run for a distance of not 360, which is run revolution, but a distance of final encoder, which is, in this case, 2400. And so we're just creating this value that is going to run until it reaches that number. And as this changes, let's say it changes to 10, that's going to turn into 800, and so this will run until 800. Instead of 360, which is one revolution, which gave us a number, now we're basing it off of inches. And we're using that unit rate and all that information that we gathered to run this program. So this program has a ton of things already going for it. It's got the inches that we need. Inside the main, we've given it inches, but we still lack the speed element. And so you're going to need to make sure that you have your forward command running with speed. Somehow, some way, we need to be able to change the speed of our quad straight function. And then we're going to do the same thing that we did with our other super user function. It'll have two things in there: integer for speed, and then the inches will be a double because we're going to have decimals.